Okay, I'm going to briefly go over inscribed angles and arcs again. So we have 10, 4, so inscribed angles of circles. Remember, when we have a circle, we have the central angle, which starts at the center. Okay, and the central angle is equal to the arc measurement. So if we have 40 degrees here, this is 40 degrees. Now, if we draw our radius or draw our diameter here instead, what we end up having is a inscribed angle. So this is circle O, and we'll have AB as our arc. So measurement of AB equals 40 degrees, same as our central angle measurement. Now, if we can figure this out, our inscribed angle here at point C, so measurement of angle ACB, we can figure it out by, well, we know this is a linear pair, so this is 140 degrees. And since these two are congruent, this is a isosceles triangle. So each of these have to add up to 40 degrees, or they have to add up to 40 degrees. So this one is 20 and this one is 20. So this proves that the inscribed angle is half of the arc measurement it contains. Now, it does not matter where the inscribed angle is. So we can have point D out here. It could be another inscribed angle containing arc AB, and the measurement of angle ADB is also equal to 20 degrees. Okay. Now, there's a couple traits about circles that deal with inscribed angles a lot. A lot of times we'll have what they call a cyclic quadrilateral. A cyclic quadrilateral is anytime you have a quadrilateral that is inscribed in a circle. And the way a cyclic quadrilateral works is that the opposite angles must add up to 180 degrees, so they're supplementary. So if this is cyclic quadrilateral A, B, C, D, we know that the measurement of angle BAD plus the measurement of angle BCD has to equal 180 degrees. And the reason that is because BAD, this measurement, is equal to half of the measurement of the arc BCD. And the measurement of angle C is half the measurement of arc BAD. Because inscribed angles are half the arc contained. So the full circle is 360 degrees. So if we know that the measurement of BCD is equal, plus the measurement of BAD is 360, then half of that would be 180. Okay. There's another trait. A lot of people don't understand this, but if I have a tangent line, so an inscribed angle is also considered, it's also considered to be inscribed if we're dealing with our tangent lines. Remember, our tangent is perpendicular to the radius at the point of tangency. So if I have a point here, it's tangent at point P, circle R, and point A is outside my circle. This is 90 degrees. This contains the arc DP. This angle DPA is 90 degrees because it contains this arc. So even though that if we have an inscribed angle, it's going to be half the arc, half the arc, half the arc, half the arc. Even though there's not a point, another second point on it, P is the second point because we're not going away from the circle. But this angle here, it basically doesn't exist. There's no distance between the circle and the point P. And so this is equal to 90 degrees. Likewise, if I draw another angle out here on the left side, and I go to point B, and I have point C over here, the angle, the arc BP, so this is the measurement of BP, is going to be double the angle measurement of CPB. 2 times the measurement of my angle CPB. Okay? And, you know, just likewise, BPD is going to be 2 times the measurement of arc, or it's going to be half a measurement arc BD. So this measurement is going to be double this angle. Okay? Remember, a full circle has to be 360, and then we break it up into parts. All right? All right, so there's a couple problems that you might have where they say, okay, we have a circle here, and we have some angle like this and some like that, and we have some central angle here, yada yada, and they say this is 96 degrees, and this measurement's 126, and we have some tangent line out here, and we'll call this tangent JH. We'll put point K over here, and we'll put L here, M and N, and they say this is 126 degrees. Well, the arc MN is the same as the central angle, 96 degrees. The angle MJN is going to be half of 96 degrees. Okay, so the measurement of angle MJN is going to be half of 96, and half of 96 is 48 degrees. Okay, the measurement of angle NJH, measurement of angle NJH is going to be half of the 126 degrees, so that's 63 degrees. The measurement of angle arc MLJ, we don't know. So the measurement of MLJ, and notice they use 3 letters because they don't know if it's a minor arc or a major arc at this time. They just want to make sure you're going in the correct direction. So what we do know is that this is 96, this is 126. So if we use our calculator and we take 360 and we subtract out 126, and we subtract out 96, we end up with 138. Now, it's not a major angle, but we can still label it with 3 letters. It does not hurt to label non-major angles with 3 letters. Now, because that is 138 degrees, now we also know there's another way to calculate this. We know that the measurement, so the first way we did was 360 minus the measurement of arc MN minus the measurement of arc NJ. The other way we can do this is equal to the measurement of arc MLJ. The other way we could do this is to say, hey, we know that this whole KJH is 180 degrees. And we know that MJN is 48, and we know that NJH is 63. So we can figure out what KJM is. KJM. So we go 180 minus 48. Okay, let's go minus the measurement of MJ angle MJN minus the measurement of NJH, angle NJH, is equal to the measurement of angle KJM. And we do know that measurement of angle, or MLJ, arc MLJ is equal to 2 times measurement of angle KJM. Okay, this one will now be 69 degrees. So 48 plus 63 plus 69 is equal to 180. Okay? There, you can see that a little better.